Hi everybody, this is our video for lesson 1.3, activity 3. We're going to be doing an activity called analyzing maps. And let me take you through a couple things real quick before you go get your supplies. So I'd like to ask you to think about patterns. What are some things that you know about patterns, or what are some examples of patterns? Think about that for a second. When I say the word pattern, what do you think of? You probably think of some kind of a textile or design pattern. This pattern here is my wallpaper that's on my wall. It's also, I've got one little strip of this wallpaper on my desk. So that's a pattern, right? It follows a design over and over again. I want you to think about patterns in nature. So immediately I start thinking about like leaf patterns. So this is a type of a plant. It's got beautiful pink and green and white stripes. That's a pattern. And of course, a zebra or leopard or any other kind of animal that has a pattern. I want you to think about other types of patterns, things that happen over and over again. A cycle could also be considered a pattern. So we've got the water cycle here. That's something that occurs over and over and over again. And even something like the seasons, that's a pattern. So when you think about a pattern, you think about something that's occurring and it happens over and over again. So the definition of pattern is something we observe to be similar over and over again. The reason why I'm bringing up the word pattern is because in this activity, you're going to use a transparency sheet to gather information from two different maps to look for patterns. So geologists will look for patterns in the geosphere, something that happens over and over and over again, so that they can make connections, find out what is causing that, why it happens, and maybe even make some predictions. So let's take a look at one of the maps that we're going to be using. This first map here is called a plate boundary map. And you're going to look at Earth's outer layer. Of course, we know key concept number 1 says Earth's outer layer is made of hard solid rock. Key concept number 2 says that it is divided into plates. Now, your computer simulation was not very accurate in the plate boundaries. This map is more accurate, so it shows the actual continents that we would find on our globe. And then the red lines there, those are the plate boundaries. So find North America, find the United States. It's right up here in this area, right next to Area A. And so we're in a plate boundary that's pretty large. But if you look over to where California is and then come down, so it's like right on the edge where Mexico is, right here, you can see that there's this plate boundary that runs right along our west coast. Some of these plates are very large, and some of them are really small. So look over here in Area D. Lots and lots of plates in this area, and they're very small. So it's not an equally divided cracking or division of Earth's outer layer. It's different and it's diversified. So remember, we talked about plate boundaries yesterday. They were the lime green lines in your computer simulation. And the definition of plate boundary is the place where two plates meet. So in part 1 of this activity, I want you to go gather some evidence about what happens where plates meet. Yesterday we saw that the plates move, either convergent, meaning they come together, or divergent, they go in opposite directions. But I want to find out what else happens where plates meet. So you're going to use these materials and investigate in pairs. I don't want you to necessarily talk about what's happening. You're just going to go ahead and do it. So this is a picture of the table in front of my screen, the Mimeo screen at the front of the room. You're going to see on the left side, I've got plate boundary maps, And then after that, I have another map called the earthquake map. And then you have one transparency sheet. Just take one, and then you need one red marker and one black marker. So go ahead and pause the video. Let one person from each table go get your supplies, and then come on back and hit play, and I'll let you know what you need to do. Okay, so now you have your supplies. Let's go ahead and get started. Take the plate boundary map and lay that between the two of you. Put the transparency sheet at the top, or like on top of that plate boundary map. And I want you to write the word top on the top right part of the transparency. See in this first picture where it says top? I want you to do that. So use red and write the word top. So then go ahead and align the blank transparency page on top of the plate boundary. And then I want you to use the red marker and trace the outlines of those 4 boxes that you see. The boxes are in black, but I want you to trace them red. And then I want you to, I don't think you have to label. You might want to label them A, B, C, and D. Oh yeah, it says right down below, label each area. So just draw an A, B, C, and D. And then the last thing I want you to do is continue to use the red marker. And I want you to trace any plate boundary line that is inside the boxes for areas A, B, C, and D. Pause this video and go ahead and hit it when you're ready to go. Okay, so you should have your, boxes marked, and inside the boxes you've got the red plate boundaries identified. Okay, so now we're going to take a look at a second map, and that's going to show our earthquake data. Before you do anything with that, I want you to think about what is an earthquake. What happens during an earthquake? So hopefully you're studying your vocab, and you may remember that an earthquake, or the word earthquake, is one of your vocabulary terms, and it's a sudden shaking of the ground, the sudden shaking of earth. There are scientific reasons behind earthquakes. They don't just happen out of the blue. We're going to do a little bit of investigating of earthquakes. But think about what happens during an earthquake. Quite literally, the ground shakes. I want you to consider a drop of water in like a bucket. You know when you drop water and then the ripple is like a round ring? So that same kind of thing happens. This was like a really quick kind of thought that I had. So let me see if I can find a picture. I'm going to put drop of water ripple. Let's see if we can find a picture of one. Perfect. This is what I'm looking for. So if you are in the epicenter of an earthquake, you would be right here in the middle. Okay. And where is that picture? Golly. Okay. You'd be right here in the middle. And all of that energy from the earthquake would really affect you right here in the middle. And then the energy from the earthquake ripples out in equal directions in all sides. So it truly is a circular movement of this energy. And it shakes the ground back and forth, just like if you had like a leaf or a bobber on that water. The ripples would bring that bobber up and down, up and down, up and down. And eventually all the energy would be, gone out. And then that would be the end of it. And it's really the same kind of thing with an earthquake. So this is what it is. Let's talk about what happens. Let's learn a little bit more about it. So the definition of earthquake is a sudden shaking of Earth's surface. And what I'd like you to do then is, in part 2 of this activity, you're going to gather evidence about the 4 areas by overlaying them on a world map that shows where earthquakes occurred between 1960 and 1990. Okay, so take that transparency off the plate boundary map and put it on top of the earthquake map. So looking at this earthquake map, look down at the bottom left. This is our key. Each one of these black dots represent an area where there was an earthquake at any point in time during 30 years between 1960 and 1990. So now what I'd like you to do is I want to make sure that you've got the top of the transparency at the top and that it aligns with the top of the earthquake map. So now your boxes that you drew should be kind of aligned with what you're seeing on the earthquake map. I want you to look at the second step. Observe what appears inside the boxes that you drew for areas A, B, C, and D. And go ahead and just turn to your partner real quick. Make sure you guys are seeing the same thing. What do you notice is occurring inside those boxes? So now take the black marker and I want you to draw a dot on your transparency for each earthquake that you see inside the boxes of areas A, B, C, and D. Go ahead and pause this video and then start it again when you're ready to continue. So what do you notice about where the earthquakes occur in relation to plate boundaries? And does there seem to be a pattern or some kind of a connection between the location of the plate boundaries and the earthquakes? This is something that I don't want to talk about. I'm not going to tell you the answer. I just want to see if you're observing it. And if you want to, go ahead and look outside the box. And as you're looking at the trails of earthquakes, think about where you're seeing earthquakes occur. And even more than that, here's what I want you to think of. Where do you not see earthquakes occurring? Look at North America. Look about where Nebraska would be. We would be right about here. Are there any earthquakes here? And I know that we have experienced earthquakes in Nebraska, minor ones. But between 1960 and 1990, we haven't really had, there's nothing there. Look at where you're seeing the earthquakes. Okay, I want to have you guys take a look at yours. And if you're looking down at the key, you see that the plate boundary is the red line, the earthquake is the black dot. It's pretty obvious. Where are these earthquakes taking place? They're taking place at plate boundaries. And so the next question that we have is why? What's going on? Why are the earthquakes occurring only at plate boundaries? And what do you think that it can tell us about the plates that make up Earth's outer layer? Okay. This is our last key concept before we move on to the next lesson, 1.4. Key concept number 3 says geologists look for patterns in landforms and in geologic events in order to better understand Earth. So when we're looking at this, we sure did find a pattern. And understanding that will help us understand Earth and Earth's systems a lot better. Okay, that's it for me. Go ahead and clean up your transparencies. Here's what I want you to do. You have your transparency. I need you to get a damp paper towel and you're going to just stay at your desk and use a damp paper towel to wipe off the transparency and use a dry paper towel to dry it. Please dry it very well. And then I want you to go ahead and reset so that those supplies are ready to go for the next group. And then when you are all finished and everything is put away, you may move on to activity 1.4, or sorry, lesson 1.4. You'll have to ask Mrs. Dalton for your student notes and for the QR code. All right, I'll see you on Monday, you guys.